direction. So there's my 5 pi over 3. What's my reference angle? Pi over 3 is gotten by doing 2 pi minus 5 pi over 3. That gives me pi over 3. What is my cosine of pi over 3? Well, how far out x-wise do I go? Not really. I don't have a circle on here. Which one? Keeping in mind one of them is 1/2 and the other one is square root of 3 over 2. You should remember those for pi over 3. You got one coordinate that's 1/2, one coordinate that's the square root of 3 over 2. That's the case for both pi over 3 and pi over 6. Which one looks like it's further out? The x one or the y one? X or y? Which one did I go further? It's hard to tell because it looks more like a pi over 4 question. The y looks like it goes further, and square root of 3 over 2 is bigger than 1/2. So this part is the cosine. That didn't come out well. The cosine of 5 pi over 3 has a basic value of 1/2. Is it going to be a positive 1/2 or a negative 1/2? Positive, because remember it is the x-coordinate in quadrant 4. We're going to be positive. So that means I need to now know cosine inverse of 1/2. The question for the cosine inverse is what angle between 0 and pi has a cosine value, oh, I forgot the inclusive part, has a cosine value of 1/2. So this is inclusive. Now notice I switched to be between 0 and pi because this is the range of my cosine inverse function. So, where am I going to be? 5/3? Oh, pi third. Pi over 3? You guys okay with that? You're voting for that? Looks good? Now I have a question. So that's the answer to this question. Looking at your answer to the last question, which maybe I shouldn't have erased, and your answer to this question, what can you tell me about the denominator of the original angle given and the output angle? They're the same. They're always going to match up. Because basically all we're doing is saying, okay, well, we were over here, we had a certain x value, we want to get that same x value over here. Or we were over here, we had a certain y value, we want to get that same y value over here. Because of the symmetries of my circle, the denominators are going to be the same because the distance of these angles from the x-axis and the y-axis is not going to change. You guys are not going, oh my goodness. Do you want to get the easier ones? I think we got some easier ones coming up. Let's see. I'm hoping. We're going to skip that one. You guys can do that. And we're going to blow that one off. We're going to do this one instead. This one, there's no way we can do by saying, oh, well, you should know what the arcsine of x over 2 is, because what's x? We have no clue. So how in the world are we going to solve this? Well, here's the way we can do these. And by the way, this is something that will work any time that you have a trig function here, an inverse trig function here, and a number that you don't know here. Not a recognizable one. So not like the 1/2, not the square root of 3 over 2, not the ones. Not the ones you should recognize. So this will work if that were the arcsine of 8/9 in there. You could use this process. Now, arcsine of 8/9 is asking for an angle measure, yes? Or arcsine of anything is asking for the angle measure that produces this sine value, yes? We don't have to know exactly what that angle is. We just have to draw a picture that says this is it. So here's my picture. Here's my right triangle. This is going to be the angle right here that has that sine value. I will never need to figure out what theta is. I just have to say it has that sine value. Now, if theta has a sine value of x over 2, in other words, so the sine of theta is equal to x over 2 is the same thing as the arcsine of x over 2 is equal to theta. They're equivalent. We're making presumptions about x over 2. We won't worry about those right now. We're saying it's okay to do this. What does that mean about x and 2 in terms of my triangle? You did it when it was numbers. X is opposite of theta, and 2 is the hypotenuse. That's easy enough. I want to find the tangent of this angle. Well, that angle is this one right here. I've set it up so that works. Now I want to basically find out what the tangent of theta is. In order to find the tangent of theta, what do I need? Opposite? And adjacent. Uh-oh, I got to find it. What do you want to call it? Y? Okay, that works. So we're going to call it y. Let's calculate what it is. Because it tells me I need it in terms of x's, let's calculate what it is in terms of x's. Y squared plus x squared is equal to 2 squared. So y squared plus x squared is equal to 4. That means y squared is equal to 4 minus x squared. Everybody happy so far? What's my next step say? Square root, so it's y equals plus or minus the square root of 4 minus x squared. And then what do I say next? Because I'm using a triangle. Length is positive. So that means this y is the positive square root of 4 minus x squared. By the way, is this the same thing as 2 minus x? No. No, you can't distribute square roots over addition. Square roots distribute over multiplication, okay, but not over addition. So now, I can write the tangent of theta. What's the tangent of theta based on the sides of the triangle? X over this thing. X over the square root of 4 minus x squared. Now this is a whole lot easier if we got numbers here, because there's no weird x's. But with numbers you do the same thing. You say, okay, here's the angle that I'm going to make the one that this describes. And we never actually have to know what that angle is in order to